Lesson 10, I will use the area model and division to show the equivalence of two fractions. This is a continuation of Lesson 10 when we were going from decomposing fractions to composing fractions. So if you remember from Lesson 10, we were taking smaller fraction parts and putting them together to make bigger parts so that we could still show an equivalent fraction. When we showed it with an equation, instead of using multiplication, we were using division. So we're going to continue that today. Go ahead and get your math journal ready. Write today's date and write equivalent fractions. We're going to do something very similar to what we did yesterday, but we're going to add a new component to it. Once you get your journal ready, go ahead and press play. Okay, the first thing I want you to do, and you'll notice it says with a partner, but I want you to do this by yourself. I want you to draw an area model to represent 8 twelfths. And I want you to rename 8 twelfths using larger fractional units. Okay, so we'll go ahead and do this together since you just started this yesterday. You may not remember exactly how to do it. All right, so we're going to start with drawing 8 twelfths. So let's go ahead and draw an area model. You're going to do this in your math journal, please. Okay, here's my model, and I'm going to represent 8 out of 12. So I'm going to divide this into 12. So I could do this a number of ways, but I think what I'll do is I'm going to go ahead and divide it into thirds vertically. And then I'm going to divide it into fourths horizontally like this. I'm going to divide it in half, and then I'm going to divide each half in half like this. All right, now I'm going to shade 8 out of 12. So far, none of this is new. You've done this. So we're going to take, I'm going to take my highlighter. I'm going to shade 8 out of 12. So remember, it's really important that when you're shading that you can still see your lines because you're going to need those. So just make sure that you're shading very lightly. All right, so I'm going to shade 8. Twelfths. Okay, now when you look at the way that I've drawn my area model, you might think to yourself, well, it's pretty obvious that you could compose these 4 units together. And you're right, it is very obvious. I want you to go ahead and circle. We're taking these smaller units and composing them into larger units. So what I have just shown here is that you can take 8 twelfths and you can show that they are equivalent to 1 2 out of 3, equivalent to 2 thirds. So you could take 8 and 12, and you would take 8 and divide it by what? What would you divide 8 by to get to 2? You would actually divide it by 4 because that's how many you put in each group. You take 12 and put it into groups of 4, and you'll have 3 groups all together. So we show that 8 twelfths is equal to 2 thirds. This isn't different than what we did yesterday, except for yesterday, for the most part, we were dividing by 2, or we were dividing by the number that we had here. So this is a little bit different, but now we're going to do something just a little bit different, okay? Here's the new part. Now, what if, and I don't want you to draw this, I just want you to watch, but what if instead of drawing my area model this way, what if I chose to draw it this way? Which I very well could have because no one told me how to draw the area model. What if I did 1 line horizontally and then I did 6 lines vertically like this, or 6 groups? So I divided each of these into thirds like this. Okay, I still have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to shade 8 out of 12, just like I did in the other one. Oops. Get my highlighter. So I shade 8 twelfths. Now this time, I'm going to decompose my smaller units. Well, this time, you might think, well, I'm going to do these in groups of 2. So I've got 1, 2. I'm still taking smaller parts and putting them together to make larger parts. And I'm still going to come up with an equivalent fraction, but I want you to take a look at what happens here. Okay, so now, I still started with 8 twelfths. But this time, I put my 8 and my 12 not into groups of 4 like over here, but I put them into groups of 2. So I ended up with 4 out of 6 instead of 2 out of 3. All 3 of these fractions are equal. 8/12 is equal to 2/3, and that's equal to 4/6. But here's the difference. This has the larger units because you can see the parts are larger. It's still the same amount, but I've grouped more together. This will be what we call using the greatest common factor. And if you made it all the way through Module 3 before it was time to move on to Module 5, you got to a lesson that talked about how to find factors. So if you did get to that lesson, that's going to be an advantage to you because you're going to understand how to do this. We're not going to use a whole lot of finding the greatest common factor in this lesson, but we are going to do a little bit of that in our problem set today. So when we get there, I'm going to show you how you can do this without drawing all these models. Okay, so let's go ahead and move on to our problem set today. And let's talk about how we can find equivalent fractions using division. All right, so first of all, you're going to notice that just like in all the other lessons, each rectangle represents one whole. So that's why each of these area models is not labeled one whole, one whole, one whole, because they all equal one whole. Compose the shaded fraction into larger fractional units. Express the equivalent fractions in a number sentence using division. The first one has been done for you. This is very similar to what we did in Lesson 9. The only thing you're going to notice is that they have more parts shaded, and we may divide by something other than 2 today. All right, so the first thing you'll see here is you'll see that these are kind of grouped already in groups of 3. So I can make equal groups of 3. I can make a group of 3 here, a group of 3 here, a group of 3 here, and a group of 3 here. So I started out with 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12, because if I count all those, they would be 12. And I put these into groups of what? Into groups of 3. 1, 2, 3. So I'm going to divide by 3 because that's what I did. I divided these into groups of 3. When I did that, I had 9 divided by 3, which was 3. And I have 12 divided by 3, which is 4. I ended up with 1, 2, 3 out of 4. So 9/12 is equal to 3/4. This is exactly like what we did in Lesson 9, except there's a little bit more shaded and there's just a few more boxes. So the numbers got a little bit larger, but the concept is exactly the same. All right, let's take a look at C. So we're going to do the same thing. Let's take a look at how much is shaded first. So we'll just do this one just a little bit differently. I've got 2, 4, 6 out of 2, 4, 6, 8, 10. So I've got 6/10. So when I look at this, I can't do equal groups of 4. I can't do equal groups of 3. The only thing I could do is equal groups of 2. So I'm going to circle groups of 2. All right, so I took my numerator, which is 6, and I divided it into groups of 2. I took my denominator, I also put it into groups of 2, and I ended up with the new fraction, 6 divided by 2, which is 3, 10 divided by 2, which is 5. I ended up with 1, 2, 3 out of 1, 2, 3, 4, 5. I ended up with 3/5. All right, so why don't you try to do D all by yourself and see what you come up with. Pause the video. This is just like what we did in Lesson 9. And then when you get yours finished, come back and we'll see if we got the same answer. Okay, so I begin with 6/8 because I have 6 out of 8 shaded. So when I look at this, I'm seeing that I can make equal groups of 2. So I'm going to go ahead and circle groups of 2. I've got 1, 2, 3, 4 groups of 2. So I'm going to take my numerator, which is 6. And I'm also going to take my denominator, which is 8, 6, and 8, and I put them into groups of 2. So I'm going to divide these by 2, and I get my new fraction, which is 3 out of 4, or 3/4. Okay? All right, now let's take a look at number 2. The directions are a little bit different. It says compose the shaded fractions into larger fractional units. Express the equivalent fractions in a number sentence using division. Actually, they're not very different, are they? They're basically exactly the same. All right, so let's take a look here. Why don't you try to do A by yourself? The numbers are kind of small. I think you can do this one pretty easily. Pause the video and then come back and let's see how you did. All right, so I'm starting out with 4 6s, and I'm seeing groups of 2 pretty easily. I can do 3 equal groups of 2. So because I'm putting these into groups of 2, I'm going to take my numerator and divide it by 2. I'm going to take my denominator and divide it by 2, and I get my new fraction, which is 2/3. 1, 2 out of 1, 2, 3. Now let's take a look at B together. I think this one's kind of interesting because there's 2 different ways that you could do this, and we're actually going to write both of these fractions just because I think it's important when we start talking about the greatest common factor. So first of all, we're going to start with 8 out of 12 because that's how many we have. We have 8 12s. Now the first way that we could divide this is to divide it like this. It's pretty easy. You can see that we have groups of 4 just like this. This looks exactly like what we did in our journals, doesn't it? So we had 8 12s, and we took the numerator and we put it into groups of 4. We took the denominator and we put it into groups of 4, and we ended up with 2 out of 3, or 2/3. 1, 2 out of 1, 2, 3. Now, we could have circle groups of 2. So that's what I want you to do. I want you to take your pencil, and I just want you to go through here, and I want you to divide these in half. So now instead of groups of 4, we have groups of 2. So we still began with 8 12s. But instead of taking the numerator and dividing it into groups of 4, we divided it into groups of 2. The same thing with the denominator. We divided it into groups of 2. So instead of having 2 out of 3, now I have 1, 2, 3, 4 out of 6. All 3 of these fractions are equivalent, except this would be the greatest common factor. This would be the smallest digits that you could use to create this fraction, still have an equivalent fraction. This actually has a special name, and we're going to talk about that really soon, okay? All right, now we're going to draw an area model to represent each number sentence. So I'm going to cheat a little bit, and I'm going to use I'm going to use my shape tool here so that mine comes out nice and even. So I'm going to draw my area model. I'm going to go ahead and draw an area model over here too, so I already have that out. All right, so I'm going to make this into 4/10. So I'm going to divide this in half horizontally, and then I'm going to divide it vertically into 5 groups, which means I'm going to draw 4 lines. Okay, so let's count and make sure. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now I'm going to shade 4 out of 10. Just remember, when you shade, it's really important that you don't cover up your lines of division that you're dividing this into. All right, so I've got 4 out of 10. Now it says you just have to draw an area model to represent each number sentence. So there's my area model. Now I just have to compose this into groups of 2 to show that it can be 2 out of 5. Right now it's 1, 2, 3, 4 out of 10, but I'm going to circle groups of 2. So that's a group of 2. This is a group of 2 and a group of 2. Now that I have composed these smaller fractional units into larger fractional units, you can see that I have 1, 2 out of 1, 2, 3, 4, 5. So this shows that 4/10 is the same as 2/5. All right, so this time I'm going to do 6/9. So you got to kind of think a little bit. You got to kind of plan ahead how you're going to divide this into 9. Well, I know that 9 can be 3 by 3. So I'm going to divide this into thirds this way, which is horizontally, and I'm also going to divide it into thirds vertically. So now I've got 3 groups of 3, which equals 9. And then I'm going to use my highlighter, and I'm going to shade 6 out of 9, just like this. All right, so now I have 6/9, and I have to show that this is the same as 2/3. And when you look at your division sentence, you can see they divided them into groups of 3. So I'm going to compose them into groups of 3. So that's a group of 3. This is a group of 3. And this is a group of 3. So it began with 1, 2, 3, 4, 5, 6 out of 9, and now I have 1, 2 out of 1, 2, 3. So I have 6/9 is equal to 2/3. Now here's the part that's new that we kind of talked about in our math journal. You can see that it says, use division to rename each fraction given below. Draw a model if that helps you. See if you can use the largest common factor. So this is that part that we were talking about in our math journals. We are going to use a model, even though it says that you don't have to do it unless it helps you. But when we do it together, we're going to go ahead and use a model. When you do your exit slip, you can decide if you need a model or not. All right, so it says 4 out of 8. So I'm going to start here with my area model. And I'm going to divide this into 8 parts. So I'm going to start by dividing it horizontally in half, and then I'm going to divide it into fourths vertically. So this is going to give me a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to shade 4 out of 8. Okay? So here is my highlighter. That's happened to me twice today. All right. So let's go back up here. So we're going to do 4 out of 8. 1, 2, 3, 4. Now, the first way that I could divide this is I could come through here and I could put these into groups of 2. 2, 2, 2, 2. And that would give me an equivalent fraction. But it says largest common factor. So I'm looking at this and I'm trying to decide, could I group these into something besides groups of 2 that would be a larger group? Well, I can't do groups of 3, but could I do groups of 4? And actually I can. I could do a group of 4 here, and I could do a group of 4 here. So now I have 4 out of 8, and I took my numerator and I put it into groups of 4. So I'm going to divide it by 4. I took my denominator, which is 8, and I put it into groups of 4. So now my equivalent fraction would be 1/2. If I did it the other way, I would have had 2/4, which also would have been an equivalent fraction, but it would not have been using the largest common factor. Okay, let's try 8/12 this time. So we're going to draw our area model again. And I'm going to divide this into 12 parts. And I think I'm just going to, divide it in half horizontally. And then I'm going to divide it into 6 parts vertically, just like this. And then I should have 12. So I'm going to go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to shade 8 out of 12. That has happened. That's the 3rd time that's happened today. I need to be a little more careful, don't I? All right, so now let's do 8 out of 12. So here's 4, 6, and 8. Okay, so I could compose these into groups of 2. I could go 2, 2, 2, 2. I could do that. But I'm looking at this thinking, well, could I do something bigger than groups of 2? I'm thinking, well, I can't do groups of 6. That would definitely be bigger, but I couldn't. There would be 12, but I don't have the shaded numbers to be able to do groups of 6. I have to be able to have equal numbers of shaded. I can't just have like 3 shaded in one group and 2 shaded in the other group. So like, for example, I couldn't do this because part of this is shaded and part of it isn't. You have to have, your groups have to have completely shaded in them, okay? So that won't work. All right, let's try something different. Let me get my shaded back here. All right, so I had 8/12. I know that I can divide 12 into groups of 3, but I can't divide 8 into groups of 3. So like if I tried to do groups of 3, I would have enough in 12, but see what happens here? I would end up with this group of 2 shaded. I couldn't make a group like this that has 2 shaded and 1 not shaded, so that won't work. Okay. All right, so let's try one more. All right, so what if I did groups of 4 like I did in the last one? Let's see if that would work. All right, so I could do a group of 4 here, a group of 4 here, and a group of 4 here. So I began with 8 twelfths, and I took each number, my numerator, and I divided it into groups of 4. I took my denominator, and I divided it into groups of 4, and I ended up with 2 out of 3. 1, 2 out of 1, 2, 3. So this 4 would be the largest common factor of 8 and 12. All right, let's try C. So this time we're going to do 9 twelfths. So I've got my area model here. And to do 12, I think I'm going to do this just like I did last time. I'm just going to go right down the middle horizontally. And then I'm going to do one right down the middle vertically. And then I'm going to divide each into thirds like this. So that I'll end up with 6 on this side and 6 on this side, which should give me a total of 12. So let's count and see if we have 12 here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to shade 9 out of 12. So this would be 8, and then that would be 9. Okay, so I've got 9 12. So already it looks a little different, doesn't it? Because we've never had one like this. But it kind of lends itself, because I'm thinking, okay, well, again, I can't do, I could, 12 does divide by 6, but I can't divide these 9 into groups of 6, so I couldn't do that. 12 would divide into groups of 4, but 9 doesn't divide into groups of 4. I can't divide 9 into groups of 2, but I could try groups of 3. So let's try this. Here's a group of 3. Here's a group of 3. Here's a group of 3. And here is a group of 3. All right, so now let's go ahead and write our division sentence. So we began with 9 out of 12, which is 9 twelfths. And we divided the numerator by 3. We divided the denominator by 3. And we ended up with this new equivalent fraction, which is 3 out of 4. 1, 2, 3 out of 4 groups. Okay, last one. We're going to try 10 fifteenths. This is going to be the biggest one we've had to do yet. So I'm going to draw my area model. All right, so I'm going to divide this into 15 parts. I think the easiest way for me to do this would be to do 2 horizontal lines, because I'm thinking to myself of an array that would be 5 by 3 would be 15. So I'm going to do this into thirds, and I'm going to divide this into 5 parts, which means I'm going to draw 4 vertical lines, just like this. And this should give me 15. So I've got 3, 6, 9, 12, 15. And I know these two are a little bit crooked, but it won't hurt. All right, so now I'm going to shade 10 out of 15. So this would be 3, 6, 9, and 10. So I'm trying to decide how I could compose these into an equivalent fraction. Well, I can't do groups of 3 because I have 1, 2, 3, but this one wouldn't be a total group of 3. So I can't do groups of 3 even though it lends itself to that. I can't do, let's see, I could do groups of 2, 2, 2, 2, 2. I could do groups of 2, but I'm trying to think of something that you could divide 10 and 15 by that would be bigger than 2. What's something that you can divide 10 by? You can make 10 by saying 10 times 1. You can also make 10 by saying 2 times 5. So that means that 5 is a factor of 10. And I know that 5 is a factor of 15 because 5 times 3 equals 15. So I'm wondering if I could do groups of 5. Look at what happens. So there's a group of 5. here's a group of 5, and here is a group of 5. That makes 5 the greatest common factor of 10 15. So I've got 10 15ths, and I'm going to take my numerator and divide it by 5, and my denominator and divide it by 5, and that gives me the new fraction of 2 over 3, which is 2/3. So I've got 1 2 out of 3. All right, so today we still are working with equivalent fractions, but we're using division instead of multiplication. You can use either to find equivalent fractions, and today we just took it a step further by trying to find the largest number that we could divide it by so that we could get the largest units possible when we are making our equivalent fractions.